In question 10C, we're asked to solve a polynomial inequality. This time it's a third-degree polynomial, and we don't have any good factorization or formulas that we can use to solve it. So that's why we learned some strategies and techniques with synthetic division, the rational zero theorem, upper-lower bounds, Descartes' rule of signs. These are all things that can help us find possible zeros. Now, I've kind of committed to you that when we have these on a test, what I will do is I'll either give you a zero so that you can get your synthetic division going, or I'll provide you with the graph. In this one, it didn't get either of those, so this is kind of a little bit out of the commitment that I normally will give you. So what we would have to do is we'd have to figure out, are there any rational zeros? So I'm going to look at the P over Q ratios to see if I can generate some rational zeros. So I want the factors of the constant, which is plus or minus a 1, 2, 3, 4, 6, and then we can go to 12. The Q stands for all the factors of the leading coefficient, so it's plus or minus 1 or plus or minus 2. So our possible rational roots would be a combination of all the ratios of, we got 1, 2, 3, 4, 6, 12 if we divide by plus or minus 1. Now if we divide by 2, we've got things such as, we could try plus or minus a half. I'm going to ignore putting the plus or minus, so we could try a half in our synthetic division. We could try 3 halves, since 2 over 2 is already 1. And 4 divided by 2 is already covered, 6 divided by 2, the rest of those are covered. So this is our list of possibilities that we would try. So if you aren't given a graph, and if you aren't able to determine where the zeros are, what you could use is your rational zero theorem and then apply your synthetic division. Well, I'm not going to spend too much of our time here searching, but a negative 2 is a zero of this function. And like I said, when you're given a test, what I will allow you to do is either I'll give you a zero, or I'll give you a picture, or I'll allow you to use technology. So this one we have a 2, negative 9, negative 20, and 12. And this is starting off as a third-degree polynomial. If I find just one 0 that works, and I have a second degree, then I'll use either factoring or quadratic formula techniques. So bring down the 2. Negative 2 times 2 is a negative 4. That gives us a negative 13. Negative 13 times a negative 2 is a positive 26, and that gives us a 6. And negative 2 times 6 is a negative 12. And negative 12 plus 12 is 0. So now we're down to a second degree polynomial. So I'm going to stop with the synthetic division, and now I'm going to look at my remaining factor, which is 2x squared minus 13x plus 6, and I'm going to see if I can get that to factor. If I can't, then I'm going to use a quadratic formula. So the only factors of 2 are 2 and 1, so I'm going to start off with the idea of 2x and x. The signs are going to have to be the same, and they both have to be negative, so minus and minus. Now I need to get to a 13, so I want to use a factor of 6 on the outside here and a 1 on the inside there, and I want to double check that gives me negative 13. So that's a negative 12 and a negative 1. That gives me negative 13, so now I know I have the right pair. So this is 2 of the factors. My third factor is an x plus 2 that came from my synthetic division. Now these are the factors that we put on our number line, so now I'm going to generate the number line and put on the zeros. So the values that are exactly 0 are a negative 2, a positive 1/2, and a positive 6. So negative 2, 1/2, and 6, and this is where the values are, as I said, exactly 0. So I want to include these in the solution, because if I go back up, I want to reaffirm that it was less than or equal to. So I want to find out when they're less than or equal to 0. Well, now I know where they're equal to 0. And if the third degree, what I want to make sure that I end up doing with this third degree is I could graph it, because I know enough about this graph. It's got a leading coefficient that is positive, and it has 3 zeros, so that means it has to start low, cross through negative 2, cross through a half, and finish high as it crosses through 6. I could use that graph to help me decide where it is less than 0, or I could use the interval line test. So I'll come back to the interval line test. Right now I'm just using my graphing strategies that we've learned to help us find a solution. So everywhere where it's below the green line is where it is less than 0. So we're going to go from a negative infinity up to a negative 2, and we want to include that in our solution. So that's a square bracket. We want to union it with. It's also below when we go between a half and a 6. So include the 1/2 and the 6 in as part of your solution set. And that's the only locations where it's below or equal to 0, so we want to include those. If you don't want to sketch your graph, then what you can do is the interval line test. So you'd pick a number like 7. That's bigger than 6. If you put in a 7 at each of these spots, find out whether your product is going to be positive or negative. So that would give us a positive number here. We'd end up with 14 minus 1, that'd be a positive number, and 7 minus 6, that's a positive. So 3 positives multiplied together would be a positive times positive times positive would be positive. And that's why this area of our curve was not included. Nothing in this interval was used. Then if we go inside the interval between a half and a 6, if we put in a 1, one of those factors I would guess is going to be negative. So let's try those on for sides here. I lost the x. So if I put in a 1 for x here and here and here, 1 plus 2, that's going to be a positive in this interval. And then a 2x times 2 times 1 minus 1, that's going to be a positive. And then a 1 minus 6, there's my negative. So a positive times positive and negative is negative. So you could continue on using the idea of the interval line test, and typically we've seen is that they alternate. So in this interval here, it should be alternating what we have here. So that'll be positive, and then here will be negative again in this third interval. So you've got a couple of different ways that you can decide where your intervals are negative or positive. You can use your interval line test, or you can simply sketch your graph based on what you know from the end behavior and the behavior around the zeros.